represented on there? Where's the dollar increase? In the formula in the bottom. The plus X, that represents the dollar increase. And then this represents the, well, for every dollar you increase it, you lose 10 people. So then what do you have there? What kind of equation is that right there? What type of equation is that? Come on, you know what it is. Is it linear? No, it's what? It's quadratic, yeah. So you multiply it out, and you want to know that function right there, just structurally, which term in this function right here dictates the shape of the function, really? What's the most? The squared, the negative x squared, right? Is that a parabola? Yeah. Is it facing up or down? Down. It's facing down. So there's going to be a maximum somewhere in there, an x value that's going to make it a maximum. The shape of this thing is some sort of parabola. You're looking for this point right there. So what do you do to find that maximum? You've done this many, many times. You have a function, you want to find the maximum. What do you take? You take the derivative, take the derivative, set it equal to 0 and solve it, and you end up with x is equal to 10. And then you need to prove that that's a maximum using the first sine graph, first derivative. So is it a max? This diagram shows it is. So let x equals 10. Oh, sorry, that's the label right there. So the answer to this would be, the fare now was $20. What's the new fare? $30. So I could ask you, like, how much money are they now making? You could answer that question, right? Well, you just plug that into the revenue function. What was there's the revenue function. So if it would be 30 times what? 30 times 300, exactly, right. So all of a sudden they're making $9,000. What were they making before? They were making, the fare was 20 and there were, how many passengers? 400. So they were making 8,000 before. Now they're making 9,000. In real life, our min-max curves as simple as this? No. There's usually more than two factors going into minimization, maximization, but not always. Sometimes it's this simple. Sometimes it's this simple. Does that kind of make sense? It gives you the function, so what do you just need to take? The derivative. Now, you might want to reorder these a little bit, or like piece them together differently. So this is what I would do first. I would make this 500 over 5 minus x over 5 first, plus what? 1/2 times, what power is that?
1 over 2.
Yeah, so it's x squared plus 360,000 to the what power? 1/2. I would write it like that first. That helps me take the derivative. So what's the derivative going to be? T prime in terms of x. What's the derivative of this in terms of x?
0.
So that just goes to 0, right? So what's this next one going to be? 0 minus what? What's the derivative of this? You should know that instantly. It's not a trick. What is it? Negative 1/5, yes. Negative 1/5. Plus, the 1/2 stays there, but what do you drop to the front now? So it's 1/2, and then it's the same thing, right? 360,000 to the now what power? But then what do you have to kick to the outside? Why? Yes, exactly. Now simplify. Look for what you can easily cancel. Well, that 1/2 can't. Well, I'll make it a different color. I like changing colors a little bit. Let's change it to this. This 1/2 cancels with that 2 right there. Don't forget this x though, right? So what do you end up with? T prime of x is equal to negative 1/5 plus, what do we end up with here? What ends up on the top of this? X on top, and then what ends up on the bottom? What's on the bottom? The square root of x squared plus 360,000. There's something missing there. What else is in the denominator? The 2 is in the denominator. The 1/2 is out front, so the 2 is in the denominator. Make sense?
Okay. Why does the 2 not go stay on top?
Because it's a fraction, 1 over 2.
Oh, that's right.
Yeah, think of it as 1 over 2, if that makes you feel better, like that. So then what do you have to do to that? What's the next step? We'll cycle back to black. Well, we want to find a critical value, right? So we took the derivative and set it equal to what?
0.
So we set it equal to 0, move the 1/5 over, and what do you end up with? 1/5 is equal to x over 2 times the square root of x squared plus 360,000, like this. And what did we do next on things like this? What did we do next? We cross multiplied, so we have 2 times the square root of x squared plus 360,000. It gets really tiring writing 360,000, I know, equals what? 5x. What do I do now? You have a few different paths. Remember, there's not necessarily one path. What do you want to do next? Someone asks, Mark, what do I do next? Yeah, I like that. So let's just divide by 2. So if we divide by 2, then what do we do? Someone new. What do we do next? Come on, what do you do? Square both sides. Sure, we don't like the square both sides. So what do you get? X squared plus 360,000 is equal to what? Yeah, you can make it 25 over 4 times what? X squared, like that. What should I subtract from both sides, David? What should I subtract from both sides?
360,000.
We want to combine the x's, so let's pick a different one. So what should I subtract? What?
Or X squared.
Just subtract x squared, yeah. So you get 360,000, right? Equals, how many x's am I going to be left with over here? If I subtract 1 from 25 over 4, what do I get? 20. Close. 21 over 4. Thank you, Andrew. 21 over 4, x squared, like that. What do I multiply by now? I want to get x squared alone, so what do I multiply by?
4 over 21.
4 over 21. And now is this where you get to potentially crack your calculator open here? So what do you end up with here? X squared is equal to what? 360,000 times 4 all over what? 21. Is that right? Now what are you probably going to have to use? Probably. So tell me what you get here. You get x is equal to plus or minus something. Everybody take out your calculator to do that. Just in terms of fractions, we subtracted 1 from that. So that's 25 over 4 minus 4 over 4. So that's 21 over 4. Just did the fraction work inside it. Do you have a number for me, David?
Yeah.
What'd you get?
68,571.4.
0.43?
Yeah.
Now, the question is, when you take a square root, you have to plus or minus it, right? Plus or minus it. So let's just check to see if that you have negative 261.861 and positive 261.861. So then you need to make a sign diagram. And then which function do you use for the sign diagram? You have x, and then what value are you testing on top? The what? What function's value are you testing on top? You've done this 100 times in this class. The derivative. There we go. The derivative. You're testing the output of the derivative. And where was that derivative? That derivative was right here. So you're taking this right here. You're taking this right here. And what are you going to plug in? You're going to plug in values. You're taking these values, plug it right here. Here we go. There it is. You're doing these values right there on top. Those are the values you're testing. So if you take these, what number is between those two? What?
0.
0 is a nice one. Plug in 0, what do you get? Plug in 0, what do you get? You should instantly see it. Negative 1/5, because the other term is 0, right? So this is negative right here. And then it might take a little work to do the other ones. Anybody? Let's see. So you plug in negative, I don't know, 300. What are you going to get? What do you think? What do you think? Tell you here. What happens here? Nothing. Right. What happens here? It's going down, then up. So what is it? It's a minimum. It's a minimum. It's a minimum. Okay, so cone in a tank. Here we go. It's a good question here. Let's take a look at this question. What's going on? Is give you lots of information and then only have you deal with pieces of it. You know, what's the volume of a cone? You've done it many times. 1/3 what? Pi r squared h. This question asks, write an expression for the volume of water in the conical tank as a function of h. Is that just in terms of h? No, you know from the diagram, you know that r over h is equal to 4 over 12. I think that's what it was? Right? Yep. So you cross multiply and you get 12r is equal to 4h. So what does r equal? 1/3 what? H. So where do you take this? Where do you plug that in now? This goes in right there. So what do you end up with? Volume is equal to 1/3 pi times what? 1/3 h squared times h. Simplify that. Combine some terms. What do you end up with? Pi over what? No, well pi, yeah, but do all the 3 times 3 times 3 is? 3 times 3 times 3 is? 27 h cubed. Volume is pi over 27 h cubed. That right there, without the parentheses, would not be correct right there. Because the one, you missed it, that 1/3 is also being squared. Be really, really careful with your parentheses. Be really careful with your parentheses. And then there's an h on the outside. Okay, so now it says, at what rate is the volume of water in the conical tank changing when h is 3? At what rate is the volume of the water in the conical tank changing when h is 3? Indicate units of measure. So this is, don't do anything yet. Look at the question. It says, it tells you something. What's the key in the question? It says when h equals 3, but look what it says in the description of the question here. What does it say about the rate? The conical tank is changing at a rate of feet per minute, right? So when h is 3, what do you know?
dV/dt equals.
Yes, dV dt is equal to 3 minus 12, negative 9. What is it? Feet per minute. So that one right there would be a reading one. Can guarantee that some people would try to do some differentiation at this point and not use that. You have to be really careful. It says the depth h in feet of the water in the conical is changing at a rate of oh wait, hold on. The depth h, dh dt. What is this one asking for? Careful.
Volume.
We almost did it wrong here. This one's asking for volume. What does that give you?
dH/dt.
We know that dh dt is what?
-9.
Well, yeah, but that's exactly. We know that dh dt is h minus 12. This one's asking for what? dV dt. So can you write dV dt taking a derivative right there?
Yeah.
Lindsay, what is dV dt from there? What is dV dt?
Take the derivative.
Yeah, take the derivative. What is it?
1/27 times 3h squared.
1 over 28. Yeah, so pi over 27?
Sorry.
Pi over 27 times what?
3h squared
Times what?
times dh.
dH dt. Exactly. Exactly. So if we want a dV dt when h is 3, what do we plug in? 3. Finish that for me, everybody. Find me dV dt. dt, you plug in 3 right there, and what does this become? Negative 9. So what's the answer become?
-9 pi feet per minute.
Negative 9 pi. This one's volume, right? So what's it going to be? Negative 9 pi feet cubed per minute. Nice. So is there more to this? It says, let y be the depth in feet of the water in the cylindrical tank. At what rate is y changing when h is 3? Give that one a start. See if you